Hello. Today we're going to have a recorded lesson about mass. You may have remembered that word. The word mass was on your pretest. Mass is a measure of the amount of matter an object measured in grams, kilograms, or anything metric. So mass, or even in the English system, it's basically a measure of weight. So as you see in this little picture, there's a little teddy bear, and then there are these little weights. When the two arrows are pointing to each other, this is called a balance scale. When the balance scale is even, or the two triangles match up with each other, then you can tell how much the teddy bear weighs if you add up how much these weights weigh. So mass is tricky. A lot of people are confused by the difference between mass and weight. Mass tells you how much matter something has. Matter is kind of a fancy way of saying stuff. The more stuff that's packed into something, the more matter it has. For example, a brick, you know what a brick that you make houses with? A brick is really dense. Have you ever tried to pick one up? It's really heavy. It has a lot of mass. A cotton ball is not very solid and it's squishy. It's not very thick, has a lot of air in it. It does not have very much mass. You could make a cotton ball that's as big as a brick, and the cotton ball would not have very much mass, and the brick would, right? So think about a melon or a pineapple. Inside the skin, they're really full of fruit. But then think about a balloon. It's about the same size as a pineapple or a melon, but it doesn't have anything on the inside. Weight is different. Weight tells you how heavy something is. We don't usually think about weight this way, but weight actually has more to do with gravity than how much mass something has. So it's a measure of the pull of gravity. Weight tells you how much gravitational pull an object has. So on a different planet or on the moon, for example, the weight of something is different, but the mass is always the same. So it doesn't matter whether you're on a planet that has a huge amount of gravitational pull or a tiny bit. Your mass, you are still the same, right? You're just standing on the moon, so you have a different weight because the gravitational pull on the moon is different. Your weight is less on the moon than it is on Earth. Your mass is the same. It's kind of tricky, really tricky. A lot of grown-ups do not get the difference between mass and weight. Every time I teach this, I always am like, I hope I explain this well. All right, so we have this, normally in class, we have these things called balance pans or a pan balance. It looks a little bit like this thing. And in class, we get to experiment with putting things on one side and then putting mass on the other side to figure out how much mass the thing has. But in class or in virtual land, we're going to have to do this with a virtual pan balance. Let's see. I'm going to have to pause for just a moment because I think I may have recorded this in a funky way. Hold on. All right. I just figured out that I did something wrong when I was recording. So I'm going to finish this recording and then I'm going to make another recording so that you can see this pan balance link, because this is really, really cool and really important. So watch this video and then you're going to have to watch part 2.